Hello, aspiring statisticians. Just do now for today, find the z-score for box of crackers. The mean and standard deviation are given. Hit pause so you got your answer. I'll rejoin you in a minute. All right, so set that up. We should come up with a z-score of negative 1.45. Yes. So what are we going to do with the z-score? Today, we're looking at what to do with z-scores. We can use a standard normal distribution table in order to achieve our learning target, which is we can use a z-score to find probability. Which really is the end goal. Yesterday we focused just on finding z-scores, and that gives us some important information. It tells us, the location, where on the bell curve it is, but really we need more than that. So we got to find the probability. So back to this question from the do now. If we were asked to find the probability that a box of crackers weighs at most 1.01 pounds, we're going to use the z-score. Okay, so we've got the z-score already. It's negative 1.45. And just from what we know already, a z-score of negative 1.45 is going to be less than the mean. So towards the left side of our bell curve. So here's the negative 1. So it'll be about halfway between negative 1 and negative 2. And since the question asks us the probability that the box weighs at most 1.01 pounds, that also means we're looking for a probability that it has that z-score at most negative 1.45 as the z-score. So probability we're after is everything from the left side of the bell curve all the way up to that z-score right here. So all the parts shaded in blue, right? So quick story break. You remember when we learned about logarithms, there were several mathematicians who came up with the idea of a logarithm and then spent like decades of their life performing all the calculations necessary to create this table so that other mathematicians would be able to benefit from their discovery of how logarithms work, right? And so then there's just a set of tables that you need in order to use the logarithms. So z-score is kind of the same story. Right, in order to use this z-score to find a probability, like every possible different z-score, to X number of decimal places corresponds with a certain probability. And that never changes because it's standardized. It's the whole idea. But we need somewhere to look up what probability goes with this particular z-score. Right? So one idea would be we just make a big table, right? 2-column table, and list every possible z-score and its corresponding probability. And you can imagine it's going to take a lot of space. So that is not the way that these tables are organized. Instead, in order to save space so we can get this into a more useful size, like a single piece of paper, instead of like a whole book, the table is organized so that we find on the one axis of the table the negative 1.4 that'll be down the side of the table, and then the second decimal place is 5. The second decimal place, we're going to look for that across the top of the table. So just as a space-saving device, the way the z-score table is organized, those first 2 digits on the one edge and the second decimal place we're going to find on the other edge of the table. So it looks like this. On the left edge, that's where we're going to find those first 2 digits. And across the top, this is where we find that second decimal place. Okay, and the other detail that we need to know is that I just wrote over the top of it here, but it's the probabilities given in this table are for the area underneath that bell curve for less than the z-score. So everything from the left edge of the standard normal distribution curve up to whatever z-score we're looking up, right? So that's just the way this table is always created. It's always going to be the probability of everything up to the given z-score, right? So those are 2 details we need to know. So in order to find the probability that we're after, our z-score was negative 1.45. So I'm going to look for the negative 1.4 down the left edge of the table. We'll highlight that. So this whole row is negative 1.4 somethings. Each of the different probabilities listed in here is negative 1.4 something else, right? And so that second decimal place we're going to find on the top edge of the table, circled in green up there at the top. And so the one we're looking for is 5, negative 1.45. So here's the 5 part. So I just need to find where the negative 1.4 on the one edge lines up with the 0.05 on the other edge, wherever those two intersect. It's going to give us our probability. So 0.0735, that's our probability. 0.0735. Okay, so just for understanding purposes, that is in decimal form. If I needed percent, just multiply by 100. So that's going to be 7.35%. Okay, and then just to give us some context, if we think about the bell curve that we've seen before, the first section in the bell curve is like 0.15%. Second section, 2.35%. And so our z-score puts us partway through this next section, right in here someplace. And so we know that the 13.5% of that yellow section, we can't split it half and half because those two chunks of the yellow section are not the same. So maybe one side is like 5 and the other side is like 7-ish, something like that, right? So really what we're looking for is the 0.15% from the tiny little green sliver, 2.35% from this red section, and then about 5. And that does in fact add up to about 7.5, which is what we came up with from the z-score table. Okay, so one of the whole reasons why we use the z-score table is because it's more accurate. We can get the exact spot that we're looking for because other people have calculated all the probabilities, recorded them in this table for us. So 7.35 is the accurate answer. This 7.5 is totally based on a guess, right? I just said, well, if I take the 13.5% yellow section and cut it into 2 pieces, like I'm totally guessing, right? I mean, it's an educated guess, but that's not accurate. So we want to be able to do better than that. All right, so we have 4 questions we need to look at. We got 3 concepts that we need to understand in order to be able to effectively use the z-score table to get our probability. So number 1, the probability given in the table will always give us the probability for less than. So whatever the z-score is, we're going to get the probability of everything from that z-score and less, which means on the bell curve to the left, right? So starting at the left edge, everything up to that z-score. So if the question changes and asks us now, using the z-score we found in the do now, blah, 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 same outcome, but we want the probability that the box of crackers is more than 1.01 pounds. Well, I can find the z-score for that outcome. It's going to be the same z-score. I can take the z-score to the table and get the same probability we just did for this first question, and that's not what I want. I want, as illustrated here, I want the other part of what's underneath the bell curve. So starting from that z-score, I want everything on the other side. I want everything to the right of that. Well, we know that bell curve represents 100% of the possible outcomes, right? So if I don't want this part that I got in question number 1, I don't want that part, then whatever's left has got to add up to 100%, right? So just subtract 100% minus this 7.35% we just got. I'm going to leave everything in decimal form, so I'm not actually subtracting from 100. It's going to be 1 minus the probability that we got from the table. So 1, it's the decimal version of 100%. So the whole thing, the whole bell curve represents one whole thing minus the probability we just got is 0.0735. Subtract that, and that will give us the probability that we're actually after for more than this z-score. So that's going to be 1265. So about 92%, 92.65%. question 3. So we're going to set up, really what we're after is this next concept we need is question 4, but we got to do a little bit of setup. So question 3, just to get us ready, calculate the z-score, find the probability for a box of crackers weighing less than, and then here's a different outcome, less than 1.21 pounds. So to find my z-score first, take that outcome, 1.21, subtract the mean, which was 1.3. It's the same setup, same mean, same standard deviation from before. So the standard deviation was 0.2. Subtract. So I'm going to get negative 0.09 on the top. Divide that by 0.2. And that's going to give me a z-score of negative 0.45. Okay, so we're going to take this z-score. Let's go look that up on the table to find the probability. So our probability is going to be, let's go find out. So negative 0.45, just as a refresher, when I get to the table, these first 2 digits, the negative 0.4, that's going to be on the left edge of the table. The second decimal place, that 5, is going to be across the top. Okay, so I need this page of my table, and I got to scroll down even further across the table to get my first digits of negative 0.4, so that's right here. So someplace in this row, and I'm looking for that second decimal place to be 5, which is the same column that I've highlighted before, the green one. So I just extend that same column down so I can see where they intersect. Right there. And so my probability is going to be 0.3264. Right, 3264. Let's take that back to our previous page, 3264. Leading 0. Okay. So question 4, using the previous z-scores that we already had, what's the probability of box of crackers weighs between 1.01 and 1.21 pounds? Okay, well, between is a totally different word than less than or more than. Between means just this little piece right here underneath the bell curve. So really, what am I after? Well, I want the probability of the larger weight that's further to the right across the bell curve, that just like the 32%. But I don't want everything from the left edge up to that value. I want just that little sliver that I just colored in on the bell curve right here. So what could I do? I could subtract the probability of the one that's furthest to the left, which I just had in question 3. It's the 0.3264. So starting from the one furthest to the left, subtract the probability of the value at the left edge, which is the one that we had up here from question number 1. It's the 0.0735. Now, if I subtract these, it's going to give me the probability that's left between those two outcomes, between the two probabilities. So this is, oh my gosh, we're going to capture, this is 9, this is 2, 1, 0, 5, 2, 0. Okay, so 0.2529, this is going to be 25%, 25.29%. Just for this little section there in green. So recap, the probability we get from the table is always going to be the probability from everything from the very far left edge up to the outcome we just did the z-score for. So that's going to be less than. If I need to get the probability of more than, that is the flip side. It's the other part of the bell curve. So take that probability from the table, subtract it from 1, is what we got here for question 2, is you can see the illustration of the bell curve. It's the other part. We shaded the complementary part of the bell curve. And then down here for question number 4, if we need between, we need to do the z-scores of both outcomes, look up the probabilities for both outcomes, subtract those two probabilities to get the probability between.